Okay, so there are two people there. Can someone tell me if the audio is working this time? How are we sounding? If we're sounding at all. Oh, I can see a little green light that wasn't there before. Aha. I must. Yes, good. I don't know why the previous thing. According to the operating system, the microphone was on and functioning perfectly. But here, for some reason, it wasn't. In a conspiratorial mood, I would say that when I clicked the button that said "Do not monetize," YouTube has just made things more difficult for me. Anyway, I was also saying that throughout this live stream, I shall be drinking a variety of beverages. I've been doing this. I've got hot things and I've got shake things. I've been going through this phase as I have throughout my life of just deciding to blend things because it's far more efficient. And so, throughout the day, I'll have this milk, egg, banana, berry, frozen berry, protein powder concoction thing that it just keeps me going for hours. So, yes. So apologies in advance for drinking in front of everyone. Been reading chapter 9 of The Fabric of Reality. That's the latest podcast episode that's out. And as always, with the work of David Deutsch, what tends to crop up are things that I didn't spot the first time around, or it prompts thoughts that on the umpteenth reading previously, I hadn't really thought. And this time, David was explaining an issue with the discrete and the continuous, the nature of our universe. And it also dawned on me in reading this section about quantum computation as opposed to classical computation apparently being based upon classical physics, that there was already at the heart of this idea of classical computation a quantum idea, namely the idea of the bit, that you only had zeros and ones. You had these discrete amounts of stuff. And David points this out in The Fabric of Reality. And people, it struck me, never actually experience change. We experience the illusion of change, but what in fact we experience, of course, and this is an ancient philosophical idea to some extent, is we experience a particular state and then another state. But we don't experience the intermediate state. And insofar as we did experience the intermediate state, that's just another state. We don't experience change. We experience some system in this state, call it 0, and then some system in this state, call it state number 1. But that gives us the illusion, the illusion of moving through these states. But of course, nothing is doing the moving. I just wanted to read a small section before I get to people's questions, because this was really what's on my mind from The Fabric of Reality with respect to precisely this kind of thing. So I'm just going to put it on my other screen over here. And so forgive me, this is almost like a live talkcast to some extent. I will be getting to people's questions later. But this, as I say, it was kind of a profound thought that it jogged in my memory from ancient ideas of philosophy. And David wrote here, and this is chapter 9, Fabric of Reality, the classical theory of computation, which was the unchallenged foundation of computing for half a century, is now obsolete, like the rest of classical physics, as an approximation scheme. The theory of computation is now the quantum theory of computation. Okay, so of course he's not saying there that the classical theory of computation is obsolete in the sense of actually being able to produce technology. Of course not. Saying that if you want to have a deeper understanding of reality and make progress on these questions of how to come to an understanding of reality in terms of physics and computation, the classical theory is obsolete. There's no point trying to pursue ever more deeply the mathematics of classical computation theory. That's not going to enable you to make progress, because the theory of computation is quantum computation. He goes on to say, I said that Turing had implicitly used quantum mechanics in his construction, but with the benefit of hindsight, we can now see that even the classical theory of computation did not fully conform to classical physics, and it contained strong addubrations of quantum theory. It is no coincidence that the word bit, meaning the smallest possible amount of information that a computer can manipulate, means essentially the same as quantum, a discrete chunk. Discrete variables, variables that cannot take a continuous range of values, are alien to classical physics. For example, if a variable has only two possible values, say 0 and 1, how does it ever get from 0 to 1? In classical physics, it would have to jump discontinuously, which is incompatible with how forces and motion work in classical mechanics. In quantum physics, no discontinuous change is necessary, even though all measurable quantities are discrete. It works as follows. Okay, so this is curious. In quantum physics, no discontinuous change is necessary, but we only have discrete quantities of things. So how the heck do we ever go from one quantity to another? There has to be this concept of motion and change with time. How can change happen if you can't pass through the intermediate state, so to speak, continuously? Or can you do that? Okay, so all measurable quantities are discrete. How can you have continuous change? Because you can't have discontinuous change. David says, let us start by imagining some parallel universes stacked like a pack of cards, with the pack as a whole representing the multiverse. Such a model in which the universes are arranged in a sequence greatly understates the complexity of the multiverse, but it suffices to illustrate my point here. Pausing there. When we say that the universes are stacked into this deck of cards, we also have to imagine they're infinitely thin. It's a continuum. So this already is going to be misleading, but what else can you do if you're trying to explain something that is beyond the experience of people? We don't have an experience of the multiverse from the outside. So in trying to picture it, let's picture the deck of cards where each card represents a universe with a slice that's infinitely thin. Anyway, let's keep going. Now let us alter the model to take account of the fact that the multiverse is not a discrete set of universes, but a continuum, and that not all universes are different. Okay, also there, not all the universes are different. And indeed, for any given universe, such as the one that you occupy now, the one that I occupy now, there is an infinite number that are absolutely identical, fungible. And when events happen, quantum events in particular, then the universes differentiate, they become different. But each of those different universes themselves have an infinite number of fungible instances. A smaller measure. So there's a smaller measure of them, but you can't count them because they're uncountably infinite. So this is the way we get over this. The mathematics works. Don't worry about it. So as he says, for each universe present, there is also a continuum of identical universes present. That's the fungibility, comprising a certain tiny but non-zero proportion of the multiverse. Yes. So even though it's still an infinite number of fungible instances of any given universe, it can still be infinite, but infinitely small compared to the other massively large infinities. In our model, this proportion may be represented by the thickness of a card. Okay, so the proportion of universes is represented by the thickness of the card, where each card now represents all the universes of a given type. However, unlike the thickness of the card, the proportion of each type of universe changes with time under quantum mechanical laws of motion. Consequently, the proportion of universes having a given property also changes, and it changes continuously. Again, the proportion of universes having a given property also changes, and it changes continuously. So this is going to explain how it is that we have these discrete values in computation able to move from one kind to another. He says, in the case of a discrete variable changing from 0 to 1, imagine the variable has the value of 0 in all universes before the change begins, and that after the change, it has the value 1 in all universes. So this is the way we're going to get this change, having both discrete values in every single universe. It either is 0 or 1, but there's a number of universes, an infinite number, a continuum of universes within this range, and they're going to change one at a time. There's infinite of them, okay? So it's a continuous change that's happening in the multiverse. In any given universe, it's either 0 or 1, which means that any observer in the universe only ever sees 0 or 1. Hence, only ever experiences 0 or 1 and not the change, because the change is happening at the multiversal level, okay? Of course, you would have the memory. Of course, you're going to have the memory if you're in the universe with 1 that it was, in fact, 0. It's just that you won't see how it got there, so to speak. It just happens. It just happens. It's the flick of the switch, if you like. If this is not mysterious to you, Great. It's mysterious to me. Was mysterious to me until reading this thing again. So he says, just to recap, in the case of a discrete variable changing from 0 to 1, suppose that the variable has the value 0 in all universes before the change, and that it has the value 1 in all universes after the change. During the change, the proportion of universes in which the value is 0 falls smoothly from 100% to 0, and the proportion in which the value is 1 rises correspondingly from 0 to 100%. It might seem that although the transition from 0 to 1 is objectively continuous from the multiverse perspective, it remains subjectively discontinuous from the point of view of any individual universe. However, that is merely I forget, he's talking about a diagram there. So that's the point. I think that's my punchline here, is that although the change is happening continuously from the perspective of the multiverse, in any one universe, it's a discrete change. This is the quantum aspect subjectively from the subjective perspective. What's the subjective multiverse perspective? The subjective universe perspective, our perspective, this perspective of a single person, an observer. There's no special physics applying to the observer. It's just that the observer only occupies a tiny proportion. In fact, strictly, we might say a class of universes, all of which are exactly the same. The fungible universes in which you yourself find yourself. You will find yourself in the state 0, and then you will find yourself in the state 1, and you go, well, how did I get from 0 to 1, given that there is no intermediate state for us to pass through? Not for you, but for the universes, for the multiverse as a whole, the proportion of universes is changing steadily from none of them are in the state 1, and all of them are in a state 0, to continuously the proportion of them change to the state 1. At some point, at the intermediate point, at exactly the halfway point, half of the universes will be in the state 0, otherwise being identical in all other respects, and half of the universes will be in the state 1, otherwise identical in all respects, and then continue the change until they're all in the state 1. This is what it means for the state to have changed from 0 to 1. But you, being in one of those universes, will only ever be either experiencing the state 0 or the state 1. Okay, maybe that's not profound to everyone else, but to me, this goes to the heart of quantum theory and reconciling our understanding of the discrete and the continuous within this multiversal model, how it is that motion is possible and that kind of thing. Okay, right. But it also goes to the heart of the mystery about what doesn't tell us what consciousness is, but how consciousness has this inherently single universe aspect to it, or at least you're in this proportion. You don't occupy the entire multiverse. You occupy this tiny sliver of the multiverse, and you are observing particular states and then observing other states, as I began this discussion with, and not the intermediate states. Okay, so that's what I wanted to talk about with that. I notice now that in looking at Twitter, I can now see how many times a particular tweet has been viewed. I suppose that's to some extent useful. Certainly there's been rapid iterations being made at Twitter. I like experimentation. I suppose rapid experimentation, but one wants to have time to reflect on the changes to figure out whether or not they've been of benefit and so on and so forth. It seems like a lot of changes are being made at the moment. So if Elon is trying to figure out, okay, is this generating a better customer experience, user experience? How do you know if you're asking people how satisfied they are with the overall experience? If there's a multitude of different changes and there's one particular change that you don't like, then that's a feature of human psychology. You tend to reflect more heavily on the thing you don't like than the thing you do like. So, for example, at the moment, I like the fact that I can see the number of views of the tweet, but on the other hand, I wanted to be able to have the facility to, as I do, being content creator and posting videos, to post longer videos. So I'd always had Twitter Blue, so it was called. Then they changed Twitter Blue, so that Twitter Blue, the thing that allows you to publish longer videos, also comes packaged with the blue tick. And I don't want the blue tick. I think the blue tick is a silly idea. It just creates two classes of people on Twitter, the payers and the non-payers. Okay, so they were there already, but why are we telling everyone now? I just don't get that. So I don't want the blue tick, but I have the blue tick now, seemingly out of necessity, because I want the other features that come with the paid model. So anyway, the point is, if you're making rapid changes, many rapid changes that seem to be going on right now, it can become more difficult, as any experiment is. You're changing many variables when you should be just changing one, sitting back, reflecting, gathering the data that you want, and then go on and make the other change. I don't know what extent this is happening right now. Perhaps it is. The James Webb Space Telescope has been, as always, releasing more exciting stuff. Another thing I want to talk about. And big deals are made about, well, they're finding planets in the habitable zone, 7 planets in the habitable zone. This habitable zone thing is over-egged quite often by astrobiologists. I think it's the equivalent of clickbait in the astronomy world. Habitable zone planets. What is the habitable zone? The habitable zone is just that region around the sun where, on the surface of the planet, you could have liquid water. Any closer to the host star and the liquid water is going to boil. Any further away from the host star, the liquid water is going to freeze. Well, what we already know about astronomy, even within our own solar system, the moon of Europa, we think it's solid on the surface. It's well outside the habitable zone of the sun. But there are good geophysical theories that say, but there might be a liquid ocean of water underneath, which could have an ecosystem, could support an ecosystem. All you need for something like that is an internal source of heat, which something like the Earth has, by the way, and Mars would have, and Venus would have, and all this sort of stuff. And Venus would say completely inhospitable. Well, I don't know how deep down under the ground you need to go on Venus before it's cool enough. Okay, you go too far to the core of Venus, and it's going to be just as hot as the Earth. But is there a midpoint somewhere there where life could be supported under the ground? Okay, so you're not going to find civilizations. But if we're talking about habitable life of any kind, well, you can be closer to the sun and further away from the sun than the habitable zone defined as where the liquid water is, and yet still have liquid water, because there will be other ways of having that liquid water there, other ways, by the internal mechanics of a particular planet, namely radioactive decay of the core, which is what's going on in the Earth. If you move the Earth, way out to where Jupiter is, sure, complex life will die. Bacteria will survive, and the bacteria will survive even if the Earth freezes over, because deep under the ground it's warm, and deep under the ground it's warm not because of the sun, but rather because of the radioactive decay that's going on of uranium primarily down there, and the heat left over from the formation of the planet 5.5 billion years ago. That's also the reason why the core of the Earth is hot, and it's cooling down over time. So habitable zone stuff. There's also a habitable zone, interestingly, if you're interested in this kind of thing, of the galaxy and the universe. The galaxy has a habitable zone. Too close to the center of the galaxy, too much radiation, stars get too close together, so the orbits won't be stable. You won't have habitable planets because they're likely to crash into each other. They won't last very long. There's too much radiation there anyway, baking the surface of any planet that's near the center of the galaxy. Further away from the center of the galaxy, you actually have a problem with what's called metallicity. There's not the great variety of elements out there. The nuclei of the elements out there are lighter, and this is related to the idea that you have a habitable zone in the universe as well. If we find planets that are extremely distant from the Earth, let's say billions of light years away, we've got no hope of seeing them, by the way. But if you could see the first planets forming, which would be Jupiter-like planets around stars, the first generation of stars, you wouldn't have life there. Why wouldn't you have life there? Because of necessity, those planets are forming out of the same stuff that the Big Bang produced, which is only hydrogen and helium. So you would have a star. Stars can form perfectly well out of that. any planets that form are also going to be like that, made out of hydrogen and helium, big gas giants like Jupiter. And you're not going to have flying bats or anything like that in the atmosphere of those planets. Why? Because what would they be made out of? They can't be made out of carbon because there was no carbon in that at that time. Hadn't been produced yet. There was no oxygen. There was no silicon. There was nothing except hydrogen and helium, trace amounts of lithium. So there's a habitable zone in the universe as well. Habitable zone in the galaxy comes down to this. By the way, I mentioned metallicity because this is the word that astronomers use for any element that is heavier than helium. Everything else is a metal to an astronomer. I know that chemists disagree. I had a few things on my list here. Oh, yes, I was listening to Jordan Peterson talking about the people who talk about people and people who talk about things. And I just found that that really interesting, his reflection on these two classes of people. Often he brings it down to gender roles. Certain females are more likely to talk about people and males are more likely to talk about things, but it's certainly not a strict divide. There are people out there. And I tend to see this on Twitter, the people who are talking about other people, the people who are engaged in giving lots of advice, seemingly, and the people who are just going on and getting involved in doing the thing, commenting on the things out there. Of course, both types are important. You know, some people need guidance and advice and all that kind of stuff. Whereas other people seem to be able to just get on and do stuff without needing too much advice. Of course, you don't know what anyone's personal situation is, but the measure of the things, you know, that old Bible passage, ye will know them by their fruits. You see people being highly productive and doing lots of stuff. They tend not to be the people giving life advice. It's the, you know, doctor, heal thyself kind of thing. The person who's got 10 ways in order to be more productive is often the person who is, what's it called, projecting. It's like, these are not so much routines that you personally have, your 10 ways of being more productive. These seem to be aspirations that you have for yourself. Because often, you know, I will look at 10 ways to be more productive. You know, not exactly that, but that kind of thing, you know what I mean? And think to myself, yes, isn't this common sense? Isn't it? Well, why is this a revelation to you that this is the way in which you get things done? Okay. Okay, I'll go to the, one final thing. I was listening to Jonathan Haidt on the most recent episode of the Tim Ferriss podcast. Tim Ferriss podcast is a great podcast. And they were talking about morality. And Jonathan Haidt has views on different systems of morality. And of course, like everyone else who speaks in this space, seems to me to miss the point. And it's the point that David Deutsch makes about morality, which is morality, like science, is a system for solving problems. That's it. Okay, you can have your scientific theory. General relativity allows you to solve problems. Evolution by natural selection allows you to solve problems. The theory of combustion using oxygen allows you to solve problems, etc., etc., etc. Okay, so you have these scientific theories, but you don't say, you know, I am a general relativist and I tend to use general relativity to solve all the problems in science. That would be ludicrous. It's absurd. But in morality, people do pick a theory. They say, I'm a utilitarian, and that's it. I use this theory to solve everything. The critical idea of knowledge is that every single theory in science or anywhere else serves as a criticism of other stuff. It's explanatory, of course. Ideally, that's what you want. You don't just want a predictive account of things. You want an explanation as to why the world is doing what it's doing. But once you have that explanatory theory, it serves as a criticism of everything else. So quantum theory sits there as a criticism of classical physics, and it wins in that battle of ideas. Classical physics serves as a criticism of, you know, John Smith walking down the road who's got his own theory of how to get rockets to the moon using his propulsion system. Well, Newton's physics will tell you that his is wrong and it can be ruled out by experiment, and Newton's theory would win that battle. But put Newton's theory of gravity in a battle with general relativity, and they're critiquing each other, and it's general relativity that wins out that battle for solving almost any problem, unless, of course, you just need something that's efficient, very quickly done, back of the envelope type thing. Then maybe Newton's physics wins for the heuristic reason, okay, for easier understanding, the easier way of launching your ballistic missile, let's say. But in morality, the rules are changed. In morality, people identify with particular theories, especially these days. The effective altruism type people and utilitarians of almost every kind, they want to mathematize these things in some way, shape, or form. I was listening to Haidt talk about this with Tim Ferriss, just morality in general. There was nothing particularly that Haidt said that I objected to, but it got me thinking about Jocko Willink one time, the Navy SEAL who's got his own podcast, which I always recommend to people. And he was asked one time by one of his bosses before he went to Ramadi in Iraq, where he led the Navy SEALs in the battle for Ramadi during the Iraq War. And one of his bosses asked him or advised him, make sure you think about, for any mission you go on, whether or not it will be worth losing one of your men over. And so this is what his boss advised him, so you basically saying, don't go out on a mission if you think you might lose someone, or if you think it's not worth losing one of your people over. In other words, he was doing the utilitarian calculus. Is this worth doing? Jocko's response was basically, sir, it doesn't matter what the mission is. No mission will be worth me losing any man over. Now, that would seem to cause him to be impotent in the face of doing anything while he was in Iraq, fighting terrorists and fighting warlords and so on and so forth. But he's not a utilitarian. He's not doing that calculus. He then went on to speak about duty. But it is my duty to do this. We have accepted this mission. This is our job, and this is what we are going to do. There will always be a risk of losing someone, always. But the measure of the mission is not whether or not it's possible or we think we might lose someone, but rather whether we do the job, which is quite right. So this isn't now other people will come along and say, oh, yes, but really, you can do the utilitarian calculus. From the God's eye perspective, it's better that Jocko goes and does the mission. And, the point is, as a matter of practicality, Jocko is not making the utilitarian calculus. What does it have to do with anything I ever talk about? Well, when it comes to AGI, right, or AI, and people trying to program in the ethics for the AI, which I think is a ridiculous idea anyway, it always comes down to this, utilitarian calculus of some kind. And yet people, it appears to me, people engaged in matters of life and death are not making that calculation. How would you make that calculation anyway? Okay, so all of that said, now I will go to questions and people's feedback and that kind of thing. And one of the things that's come up is, of course, AGI and AI and Chat GPT and that kind of thing. So I'm just looking at Twitter now. Arjun, of course, has said, topic suggestion, Chat GPT and AGI. So interestingly, this is my side hustle. I shouldn't say that. So making podcasts is one of my hustles. There are things I do in life. Okay? So this is the public-facing part of me. One of the other tasks I shouldn't say tasks, I'm really enjoying it, but I am in the very fortunate position of being able to learn precisely about this thing. A few of us were absolutely fascinated, impressed, amazed by the capacity of Chat GPT to do what it does. And I wanted to find out, and others wanted to find out. And so we are building a thing to explain how this thing does what it does. Can't say much more about where that's happening, when it's going to be released or anything like that, but it's going on. So I've been doing the work of trying to figure out the technical details that sit behind Chat GPT in particular, because Chat GPT uses this new mode of generating predictions. It uses this thing called the self-attention transformer, which is a highly mathematical, very sophisticated way of weighting certain guesses that it makes. I say guesses with the proviso they're not genuine guesses. There are two things to say about the way ChatGPT and self-attention networks work. Okay, there were these things called recurrent neural networks, which were able to make predictions, but they didn't work well for things like language translation. A group of very smart people published a paper called Attention is All You Need, also called the Transformer paper. And people have been using this transformer, this new algorithm, this new way of weighting stuff in order to create things like ChatGPT. The reason why ChatGPT is so good, this is not a full explanation, but the reason why it is because of this thing called the self-attention transformer that sits behind it. It's the algorithm behind it. But that's not all. That's just the algorithm. You need to give the algorithm something. So what do you give the algorithm? Massive amounts of data. And when I say massive amounts of data, it is difficult to imagine the amount of data. One of the earlier, this is not ChatGPT, but an earlier iteration using GPT-3, which also led to particular impressive chatbots. That earlier version, which was not as impressive as ChatGPT, it used something like 42 terabytes of data. Okay, so 42 terabytes, yeah. We know what a terabyte is. You buy, disk drives, SD drives, and DD drives, hard drives are of the terabyte size. This is 42 terabytes of text, not images, not movies, not text. This is what it was trained on. That's a phenomenal amount of textual data. I did the calculation just for fun as I was researching this stuff. If you had regular Bibles, regular sized, New Testament and Old Testament Bibles, and you had I was using feet because I was talking to Americans, and if you had a 6 foot tall by 9 foot wide bookshelf, and you filled that bookshelf with Bibles, and then you had another bookshelf behind that separated from the first bookshelf by 2 feet, and you filled that one up with Bibles. Repeat that process for something like 25 miles, and you'll have that amount of data, 42 terabytes, something like that. Okay, I might get the numbers slightly wrong, but it is in the order of 30 miles, something like that, of bookshelves filled with Bibles. Phenomenal. And apparently this ChatGPT one is much, much bigger than this. They're very cagey about precisely how much data was used. But this is the reason why it's so impressive. So why is it so impressive? Okay, so it's got this algorithm, this self-attention algorithm behind it, which it uses partial differential equations. It uses probabilistic assumptions. It's this kind of Bayesian thing that it's impressive. It's an impressive piece of mathematics, but it remains a piece of mathematics, not self-aware or anything like this. So what does it do? There are very few good popular accounts of how this thing works. To some extent, I've come to think myself that no one really knows precisely how it works. And this is not uncommon, by the way, especially in the field of coding, phenomenally. The programmers of AlphaGo, the thing that beat the program that beat the players of Go, were unable to account for how it made the moves that it did. Okay, so they didn't know how it worked. That just means they don't know. It doesn't mean that it's doing anything magical or literally intelligent. They didn't know. Okay. In the same way, it appears as though from the accounts you read out there, you either get really, really technical mathematical accounts, super abstract accounts, or just accounts that are perhaps too superficial of this the transformer. Okay, the attention is all you need paper, how this thing works. I likened it to what they do with this vast amount of data, this vast amount of this 42 terabytes of text used by the ChatGPT. More than that. Okay, the previous version of the chatbot. And what ChatGPT now does is it builds an abstract space of relationships between words and phrases and indeed paragraphs. And the landscape is literally like a landscape. It has the analog of mountains and rivers. The mountain might be, the example I used was, you might have a mountain that sort of represents cats, the concept of cats. And it's got faces like teeth and fangs, and it's got leopards on one side and lions on the other, and it's this big thing. And so related to that is all the concepts related to cats. And next to it is like the mountain of dogs and all the different species of dogs and the features of dogs. And then you've got this huge mountain range of mammals part of more mountain ranges, which are animals in general. And then life in general is this huge continent of stuff. And then you've got this ocean of abstract notions about mathematics and so on and so forth. And it just becomes this world of data with features that it builds. And by the way, this training, you feed all this data, this massive amount of textual data into the algorithm that ChatGPT runs. And it takes a long time for it to learn all this, it feeds output and then it takes back input. It's got forward propagation and backward propagation, so they call it. Training this thing over a long time. Eventually at the end, it gets this model, this abstract space of existing knowledge, because the existing body of knowledge is just like a library. It's the stuff we already know. And given that, it can then extrapolate and interpolate and produce things that fit in the landscape. It can make up something that isn't in the landscape but fits in the landscape. It appears to fit in the landscape. It resembles stuff that's already there in the landscape. Do you know what I mean? And so this is a new mode of doing stuff, it seems to me. This is the way I've explained it to myself, because those accounts aren't out there. This idea of generating this abstract space, this landscape of concepts. But what we can say about that, because people ask about AGI, as impressive as that is, that building of the landscape and the providing the illusion of an actual entity there having a conversation with you intelligently, there's a big difference between that kind of thing and an AGI, or a person who can gain escape velocity from the landscape and say something that is completely a new world, altogether a new world. If the chatbot, if ChatGPT has no knowledge whatsoever of constructor theory, it's not going to come up with it. But of course it does. Anything that's out there, anything that's being published, just about, almost anything that's being published, will somehow or other be in ChatGPT's memory. But it's not going to solve new problems that no one's had before. It might solve a problem that you personally have. Why? Because someone else might have solved that problem before, and so it can just grab that solution and give it to you. Which is why people are also saying ChatGPT is a new form of search engine. Google does the same thing, but no one's tempted to attribute to Google intelligence. But they are tempted to attribute to ChatGPT some kind of intelligence, because it's crafting sentences that fit into the landscape of sentences that already exist. But it just won't come up with anything entirely brand new. Okay, won't solve humanity's problems, whereas people will. So that's a stark difference. Okay, so that's my thoughts on ChatGPT and AGI from Arjun. Ronald has asked, talk about the simulation theory and the Penrose argument about the universe not starting with a bang. I don't know what you mean about the simulation theory, unless you just mean the simulation hypothesis that Bostrom comes up with. I've talked about this before, at the risk of, I guess, boring people or repeating myself. The idea is that, let me just give you Bostrom's argument. At some point in the distant future, our computational capacity will be so great that we will be able to simulate within our computers whole worlds. We can already do this to some extent with, pick up Microsoft Flight Simulator. It's a simulation of the world to some degree of fidelity. The Sims, that game, is a simulation of the world to some degree of fidelity. You can imagine in the distant future, we'll be able to simulate the whole world to high fidelity. And if you're simulating the world to high fidelity, then in that world, you're simulating the goings-on of matter doing absolutely anything. Presumably you'd need a quantum computer for this, or perhaps not. But inside of that computer, if it's a very, very good representation of the actual world, it will have people in it, because the world has people in it. And so there's people wandering around inside this simulated world. Okay, well done. That's a physically possible thing to do at some point in the future, because we already know that the laws of physics are computable. So anything that happens in physical reality can be put inside of a computer. That includes thinking people. Okay, so you've got a planet Earth, let's say. You could have a universe or a galaxy, whatever, in your computer. Well, if it's a good simulation of the world and it's got people in it, then those people will have computers. And on their computers, they too could run simulations of worlds with people who have computers, who can run simulations of worlds with people, with computers, and so on. It goes into this fractal type thing where it's just there's only one base reality, physical reality, and then everything else is simulated. And so Bostrom's argument is by probabilistic methods, where would you expect to be if you pick yourself out of a random universe? Is it a simulated one or the base real one? Well, he thinks the way to solve this is to say, well, you should expect to be in a simulation. But it's the wrong way, of course, to count these things up. These things are uncountable. We live in a multiverse, by the way. So which one are you in? Which branch of the multiverse are you in? The one where it's been simulated or the one where it's not been simulated? We're already comparing uncountably infinite numbers of things. But besides that, if we are in a simulation, as I said just as recently as the last episode of Talkcast, in fact, if we are in a simulation, then that doesn't solve anything at all. We want to know, when I say we, people who are interested in the foundational questions about existence want to know what the ultimate constituents of reality are. We also simultaneously know we can't get there, but we want to know, this is our aim, this is what we're aiming for, the answers to our deepest questions. So if you just say, oh, we're being simulated on a computer running somewhere in another universe, we just want to immediately ask, what are the laws of physics like in that universe? Oh, well, that's also a simulation. Okay, well, forget about, okay, once you get out of the simulation, what are the laws of physics like in the universe that's not being simulated? That's my real question. And why do they have that form, and etc. So it doesn't solve anything for us people who are interested in answers to questions. Don't just palm us off with, oh, look, here's an interesting way to avoid answering the question. It's exactly like people saying, don't worry about it, God created it all. And you'll find out when you die. Well, it's not a solution to anything. That doesn't satisfy our curiosity. That's palming someone off. It's saying, we don't know why reality is the way it is. Consider this. When it's just not an answer. Better to just say, we don't know right now. But I would say it's not a simulation because that's a bad explanation. It's too easily varied. There's no state of the world in which we can ever rule that out. Sure, it's fun to think about, but it's fun to think about, as I like to say, and one of my philosophy lecturers used to say, everything you observe and all the laws of physics and all the explanations you have are perfectly consistent with the idea that reality, all of reality is just coming to existence right now, and with your memories intact, and any moment it can wink out of existence too. Okay, that's just as profound a thought as the simulation argument, to my mind. Who cares? It doesn't allow us to make progress is the main point about all that stuff. Okay, so thank you, Ron. Oh, the Penrose argument about the universe not starting with a bang. Yeah, I went to a lecture with Roger Penrose. It was at the Sydney Opera House, of all places. One of my good friends took me decades ago now. And he talked about this. And it was a very interesting idea. Roger Penrose, Nobel Prize winner in mathematics, physics, I think, but, mathematician, essentially. And his idea was the Hindu type idea, the idea of the universe existing in infinite cycles. It's theoretical. It's better than the simulation argument because there's sort of observations that kind of suggest that, well, I wouldn't say suggest, but he's trying to explain actual observations, actual problems. So what he says is, well, look, if our current observational data is correct, the universe is expanding, not only expanding, but accelerating in its expansion. This is the way I remember it anyway. Then what you have towards the end of time, trillions of years hence, is a universe where everything has expanded away from everything else, and from any observer's perspective, let's say you're here on Earth trillions of years from now, then all the other galaxies have expanded away from the Milky Way. Okay, let's just make this simple. The stars are still alive. Of course, they're not. The stars have long since died. But if you're there somehow, you're an artificial intelligence. You've managed, it's artificial general intelligence. You've managed to put yourself into some sort of robotic form. So no matter what happens to the sun and everything else in the entire universe, the matter you're made out of is extremely robust, and you have survived trillions of years. The universe has expanded, space is expanding, the galaxies have expanded away from you. Eventually it comes to a point, because of dark energy, that the dark energy expansion will pull apart even the planet Earth, will begin pulling apart molecules, begin pulling apart subatomic particles. What do you get when you pull apart subatomic particles and you destroy matter? You have to conserve the energy. So what's left is just photons, nothing but photons. So the very end of the universe, because of the expansion of space due to dark energy, rips apart all matter into nothing but photons. So all you're observing is photons. When else did you only ever observe photons? The Big Bang, at the moment of the universe is coming into existence. And so this is Penrose's kind of idea. This is my butchering of Penrose's idea, but that's the basic concept. And it's consistent with observation. We know that the universe began hot with nothing but photons. We know, by which I mean our best explanations now are that there is this thing, dark energy, there is this accelerating expansion, and the expansion will continue forever. There's no force to stop the expansion. And so given that state of affairs and the accelerating expansion, everything will be ripped apart in some trillions of years' time. And so the end of the universe comes to resemble in some way the beginning of the universe. So clocks don't seem to make sense at that time. There's nothing to keep time at the end of the universe. So do you just get another kind of beginning? Does it just all begin again? This is Penrose's kind of idea. I don't understand the subtleties, but this is the basic concept. We began with photons, we end with photons. There was no time at the beginning, there was no time at the end. Maybe it's all a big cycle like the Hindu religion suggested. Yeah. Take that for what you like. Now, the other thing to say about that is, of course, with dark energy predictions, logical deductions from dark energy observations that we have right now, we don't know the nature of dark energy. We do know that the universe is accelerating its expansion. We have to talk about what's going to happen in trillions of years, right? Because in billions of years, the universe is just going to be bigger. If you're in the Milky Way, things will look roughly the same. You have to think in terms of trillions of years before you get radical change to the structure of the large-scale structure of the universe. And so what we say about that is, well, what do we always say about that? You know, this is prophecy to try and predict something, even if it is coming from good physical theories, because we don't know what knowledge we will create before then. Can we figure out something that would be able to take advantage of this dark energy and reverse it in some way? Perhaps. We don't know. We don't know what's going to happen in 1,000 years, let alone trillions. So am I worried about the expansion of the universe into absolute nothing, maximum entropy, nothing but photons? No, because problems are soluble. And we don't know that there's a physical law standing in our way of preventing this kind of thing from happening, okay? And somehow gathering the energy that's in the universe, there's a lot of energy in the universe, to prevent this accelerating expansion. We don't know what's causing the accelerating expansion. Maybe once we do, we can reverse it. Someone says, just finished reading Universality chapter on BOI. I'm not 100% clear on what makes some exploration universal and not others. The idea of universality is just that one way of looking at it is a particular system or machine can do all tasks that all other specialized systems or machines able to perform similar tasks could do. So it's a thing that can do everything in a particular class of stuff. So the English alphabet is universal for making words. It doesn't matter what the concept is. It doesn't matter if you invent a new chemical or a new idea. The English language is universal for being able to put letters together into words to capture that idea. Okay, there's nothing you can think of that can't be put into words to some extent. But just because you can't do it doesn't mean it can't be done in principle, is what we're saying. Okay, sometimes we have inexplicit ideas and we can't put it into words because we don't yet have the knowledge of how to do it. But the English language is such that it can represent anything that can be represented in language. Computers are the other kind of universality we often talk about. A universal computer is a device that can perform the function of any other computer. Okay, so if you've got a specialized computer that can only do addition, the universal computer can do that. If you had a specialized computer that can do nothing but run flight simulators, well, your universal computer can do that. So this is what universal means. Yeah. What makes some things not universal? Well, again, I'll just hark back to my previous podcast. Curiously, David was talking about the Antikythera mechanism, this 2,500-year-old device that was found, Greek in origin, ancient Greek in origin, made of very sophisticated, finely machined cogs. And the best current theory is that it was used as a way of predicting to very high precision the motion of objects in the sky, even eclipses, even down to eclipses. So this is a special purpose computer, analog computer, a special purpose computer. And so, but any universal computer could do that job as well, predict the position of planets. I had the thought, I don't know, this is true, but the Antikythera mechanism, it's an interesting idea that as the Terry Freer, or whatever his name was, the fellow, the scientist that actually has done the most work on figuring out what this thing is and how it works and so on. He talked about how it could be a military type device, it'd probably be top secret in some way, shape, or form. It'd be like the nuclear weapon of the time, or the quantum computer of the time, perhaps. If it was this exceedingly expensive and rare bit of technology, which it may have been, because it's not like we're finding them everywhere, in the archaeological record. There's one example of it, 2,000-plus-year-old computer. Then if you're the leader at the time, would you use it to keep yourself in power? Would you use it for nefarious reasons? Would others who've figured out that secret knowledge at some point, even just ignoring the Antikythera mechanism, if you've figured out how to predict the motion of planets, you've got access to an astronomer who knows enough about this stuff. Do you use it to keep the population in control? How would you do that? Well, you tell the population, hey, tomorrow at 2 p.m., the moon is going to be covered by the sun. If you could do that 2,000 years ago, that's a pretty impressive feat. No one else can do that. It appears as though you can do magic. It appears as though you've got access to the gods. Good way to keep yourself in power in ancient times. Of course, now we know, being in our culture of criticism, that we know there's no magic. We know that the leaders don't have access to the gods. But back then, perhaps not. Perhaps people were less critical. So, any kind of knowledge of that sort is going to be of great use to prospective dictators and so on. Rob has asked, can every proof by contradiction also be shown without contradiction? I guess so. I'm not sure. This is a mathematical question, really. But it would come down to there must be other routes to getting for any proof. There must be multiple routes to getting there. So I would say the answer is simply yes. Okay. You can imagine a proof by contradiction of the Pythagoras' theorem. There are hundreds of proofs of Pythagoras' theorem. Whatever can be proved one way, there must be more than one way of getting there, I would guess. What else have we got? Roshan Ali has asked, hardware and software of the brain in the context of mental illness. This is a favorite one that comes up quite often. So I'm not a great proponent of this concept of illness being applied to the mind. I think it's a category error because one is the abstract and the other is the physical. And illness, probably considered as a malfunction of something physical in your body. This is why you go to the doctor, okay? There's no amount of thinking that can get you through this thing. The bacterial infection is a physical problem. The the amputated arm is a physical problem. Okay, so it's not an illness, but you take my meaning. The high blood pressure, the whatever. These are things that you can objectively measure using some instrument. In the case of an amputated arm, of course, you can see the thing. But I mean, blood pressure, viral load. There's going to be some device, some measurement you can take. So you've got an illness. Here's the objective sign that everyone can agree. Now, when it comes to the mind is the thing that creates ideas. And that can go wrong, sure. But to call that also an illness, I think it's conflating different levels of analysis. We can say that people have bad systems of thought. Absolutely. Absolutely we can. And that things that lead to depression or cause people to be more quick to anger. But yeah, I think that in general, what we're talking about when it comes to so-called mental illness is a problem of software. That there are certain people, for example, who become angry more easily than others. And you might call this mental illness, My guess is, though, it often comes down to bad ideas. Here's a classic case. Like, we just don't know what the relationship between alcohol and people suddenly erupting into anger happens to be. But, I can certainly imagine that two people who otherwise have the same kind of experience with the same quantity of alcohol, have the same sensations and feelings and all that kind of stuff, can nonetheless express different degrees of anger when the angry thing, when the thing that annoys them happens. It has nothing to do with genetics. It has nothing to do with the alcohol as such. It has everything to do with the ideas, what they're thinking about, the sensations they're having while they're drunk and angry at the same time. One of them realizes, oh, I'm drunk. Oh, that's annoying. Oh, I better sit back because I'm drunk and reflect on this. That's a whole bunch of ideas that they have. And the other person doesn't have the idea that their ideas are warped by feeling angry and alcohol. But I think people can be trained from one to the other. And so we label these things mental illness when a person just persistently, routinely, habitually engages in the bad behavior. Hard-nosed on that, I suppose. But yeah, then there are other kinds of genuine mental illness, like schizophrenia. Absolutely. Okay, there's a genetic component there where people's there's absolutely a complete and utter inability of the conscious mind to control what's going on in the unconscious. Absolutely. Okay, we have unconscious minds. But modulo that kind of stuff, modulo brain problems, because that would come down to a hardware issue. The overwhelming majority of things that people, complain about in others or in themselves are a matter of ideas. And people underestimate, and I think it dehumanizes people to underestimate their capacity to change their circumstance, or at least with the help of a wise and knowledgeable guide, which might include the psychiatrist, might include the counselor, might include the psychologist, to provide them the ideas to get over it, to get over the bad ideas that they have, to provide them a new way of moving forward. Now, that said, does that therefore mean that things like antidepressants, that things like, benzodiazepine, that a whole bunch of different drugs won't be useful or have never of any facility to a person with the so-called mental illness, which I'm saying isn't real? No, not at all. Sometimes we don't know. The psychiatrist doesn't know how to help the person with the bad idea. Sometimes the person with the bad idea doesn't know how to get over the depression. Some people lose, parents and grandparents and fall into a terrible depression and can't get over it. Others go through the same thing but get over it. Well, I say get over it. They can function better in society and can still have a joyful life in a way the other person can't. This was not a physical thing that happened to them, the loss of someone they cared about. But it's had this devastating effect that they don't know how to get over. Firstly, counseling is going to help them. For some people, will the drug help? Absolutely, because they don't know how to generate the idea in time. And so as we've also said, it might not be the case that something like an antidepressant actually makes you happier. It might just lower your standards for what happiness is. And so this is also a way in which we think of the mind as being a kind of software, which if you can tweak the software without ever worrying about the hardware, that's always preferable if you can do that. It's always the beginning of infinity. There are always open questions. I just think that it's important because of the culture that we always exist in a culture. The culture right now is saturated in the idea that people need to be medicated. People need to immediately jump to the pill to solve the mental illness problem. Everyone's got mental illness. We've all got anxiety and depression. By any metric, this is what we're being fed. This is what we're getting. In the United States, you're constantly fed these advertisements about, how you should want to feel better and take this pill and so on and so forth. Without being told, maybe you don't need that. Maybe you can reflect upon ways in which to improve yourself without trying to affect the chemistry of the brain. Okay, that's off on a long tangent. All that we were asked about was hardware and software in the brain in the context of mental illness. Kyle Baker has asked me, what are your thoughts on the World Economic Forum? Yes, well, genuinely a danger to civilization, genuinely. Klaus Schwab, it is unfortunate where we have these supranational organizations that have the pretense of doing something useful in the world, but on analysis, they're about global social control. And he absolutely is. And the World Economic Forum seems to be absolutely fixated upon what people are doing about climate change, how they're using their money, controlling not merely things like pandemics, but people's individual reactions to pandemics, being able to monitor people. It appears to me that very many of the prescriptions coming out of there are nothing but the Chinese model of how to organize society. One of the greatest errors that were made, I think, during COVID was to first look to the Chinese at what they were doing and emulate that. It's the first time it's ever been done. And it was done with remarkable speed. And I think that's frightening. I think it's great that the vaccine was produced with remarkable speed. I'm concerned that, that the other measures that were taken were also done with remarkable speed without any good reflection on things. I'm concerned about things being made compulsory. The World Economic Forum is not a democratic institution. It's got a whole bunch of dystopian ideas. And the more time I spend doing stuff like this, the more I don't know, to some extent, one feels as if the tidal wave of pessimism and authoritarianism and anti-humanism just continues to crest ever higher. And governments of the world, nation states of the world continue to, in response to these philosophies, grant ever more authority and power and decision-making to non-democratically elected institutions. And it's absolutely remarkable to me as well, the public intellectuals of the world are seemingly in full support of this. You hear people speak about how, well, global government ultimately is the way we need to go. We need to go that way because we can't have the United States and China and Russia, engaged in possible conflict. Why not? Why not? Why is that a less preferable state of affairs than global government? If you have a global government, there is no escape. In this sense, for the time being, there's no planet B. So, in the far distant future, there's already planet Bs that we've discovered out there, but there's nowhere to go right now. We can get much faster to a global government than we can get to interstellar space travel, is my concern. So that if we have this hugely powerful World Economic Forum, United Nations, whatever, can legislate from the top down, there's nowhere for a person to go. The United States is such a wonderful experiment because, at least in theory, if you don't like the legislation that's being passed in a particular state, you can go somewhere else. If there are severe restrictions on rights in one place, compulsory vaccinations, you're not allowed to own your own gun, etc., 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 going on in one state, then hop in your car, move your family to another state where you can do these things. And this is the great United States experiment, which doesn't happen anywhere else in the world, really. To a much lesser extent, we have it in Australia, much lesser extent. Federal government has more power, but also Australia is a different case altogether. Our tiny population, is by comparison to the United States. It means that there's generally not as much polarization. The cohesion is a little greater, and so you move via grey scale from caring about your household and family to your local community, to your state, to your nation. And Australia is more like a state. The whole nation of Australia is more like a state. It's more like California, or it's more like Texas, or it's more like Montana than it is the United States, right? It's more like that just because of the population. And so, if things get terrible in Australia, we can go to New Zealand. At the moment, you wouldn't want to go to New Zealand because things are terrible there. But if things get terrible in Australia, in theory, you can sort of get out, go to the United States. And the United States seems to have this constitution where you still do have state rights to a large extent. So, the people who don't mind walking down the street, behind people who are, smoking marijuana like a chimney, that's fine. Okay, there you go. You've got California. If you don't like that, for whatever reason, you don't like that, then you can go to a state where that's not permitted. If you like a place where people are walking around open carrying guns, you can go to Texas. And if you don't like that, then you can go to New York. Okay, you've got that choice. That's a wonderful choice in the United States. The problem seems to be the federal government, because then everyone has to somehow agree on the federal government. Then the federal government wants more power, etc. But Australia's not quite like this. So my thoughts on the World Economic Forum, the same as my thoughts on the United Nations, is the more that you concentrate power at the top, the less choice people tend to have, and that worries me. And just in general, their worldview is that people are a problem. And of course, the World Economic Forum in particular is very much about let's distribute, a little bit more money to these people and take it away from these people. It is a control of world economies, which it does not need to exist. Under free market capitalism, it's bottom up, and you don't need anyone with a hand on the scales controlling stuff. You need someone. You need the police force there to ensure that there's not robbery going on. Okay, there's not coercion and force being used. But beyond that, the government doesn't need to be involved. Certainly not a global organization that's concerned about trade. World Economic Forum. Okay, yeah. So that's that. Now I'm just clicking on Twitter to see what else we've got here. A few other questions here. Or someone has said, Hervé, time does not flow. The past, the present, and the future coexist. Does this mean that in the multiverse, all that can possibly happen as per the laws of physics has already happened in an infinite timescale? So obviously, if you step outside of time, if you could have a God's eye view of the multiverse, which you can't, then you look down and you see the multiverse, and you see the past, the present, and the future are all equally real. Okay, yeah, so that's true, but that's not our circumstance. To some extent, it's kind of an uninteresting fact about our circumstance as well, because we are in a universe, and subjectively, everything's open to us. But I also tend to think that knowledge creation is an actual act of creation that we do not understand yet, and we're yet to grapple with. And so to what extent is the future open? I think entirely within the bounds of the laws of physics. So although everything that can possibly happen happens in the multiverse, and we can't get outside of the multiverse to look anyway, then it genuinely is the case that people have to work hard to create the knowledge, because it's not going to happen inevitably. We have to create the history. Although it's possible that, the cure to all cancers will come, and in some branch of the multiverse that happened, that branch of the multiverse where that happened could also be infinitely thin, very, very thin, the thinnest possible branch that you can imagine. It happened because it's possible to happen. And it's not a genuine history because it's a sequence of accidents that's happened. It appears from the person who occupies that universe where all cancers have been cured, that branch of the universe where it's possible, and you can just say, okay, it's possible that in some part of the multiverse, all the cancers on planet Earth have been cured. From the perspective of that person looking backwards, although it appears as though a whole bunch of causes and explanations were created, in fact, they never were. It's just coincidence after coincidence that has led to that. In other words, a Harry Potter type universe. The real universe, creating, conjecturing explanations, would proliferate across the multiverse and create a very large structure that is resilient, this thing called knowledge. And so in that way, although everything that can happen does happen, here we have a situation where that thing that can happen does happen a lot and is replicated across the multiverse. And that thing's called knowledge. Okay, so there's a distinction to be made between just any old random thing that happens consistent with the laws of physics and the thing that happens a lot in the multiverse precisely because we've generated the knowledge of how to do so. Okay, this is to do with, again, you have to go to my multiverse series on this, the thing called Harry Potter universes, which was a thing coined to by early readers of the Fabric of Reality, when we considered these ideas about extremely low probability, extremely low measure events where certain things happen only exceedingly rarely. Okay. But yeah, time does not flow. And this also goes to the thing I started this whole live stream with, is that as a matter of conscious experience, you experience a particular state, then you experience another particular state, and then you experience another particular state. So you're not experiencing change, you're just experiencing states. But to get from one state to the other, you don't experience the thing that got you from that to that. It's a discrete movement. I say movement. Yeah. So time's not flowing. Correct. The illusion of time is flowing is all that we have. Okay, I'm going to go to questions here on YouTube. The chat's been going on. I've been ignoring the chat, so now I'll come to the actual chats. Lionel. I don't cut Lionel. Okay. He said, hi, Brett. I would love if you read or discuss philosophy of physics books later on your podcast. Also, what do you think about modeling theory of David? I don't understand that question, I'm afraid. I'm sorry. Did ChatGPT write that? Sorry, Lionel. I can't pass what you're saying. You might want to rephrase. The modeling theory of David has tenses. I don't know it. Moritz, what is the goal of AGI, a person? Or he's also asked, what do you think about doing a Twitter space with a bunch of CR people? More questions. Okay, so what is the goal of AGI? The whole purpose of AGI, by the way, and a person is we don't have goals. That's the difference between a specialized intelligence, okay, the prosaic artificial intelligence, narrow AI, and general intelligence. The special intelligence can be given a goal and it will only ever pursue that goal. That's it. It can't think outside the box. A person is never really given a goal. You can think you've got a goal, but you're going to get distracted. And so you will not relentlessly pursue that goal, as disciplined as you are. You're always going to think creatively. What's the point of pursuing AGI? I guess out of curiosity, if you're asking that question, what is our goal in generating AGI? Curiosity would be the main one. We want more people in the world. More people create more solutions, lift us from worse problems to better problems. People are the way in which we improve the world. More people is always better. Almost always better. Okay, we're in a situation now where more people are better. There might have been a time in our history static societies where that wasn't the case because more people are more mouths to feed. We're not in that situation anymore. It is the case they're more mouths to feed, but we've got enough resources and we'll always have more resources. So, yeah. What do I think about doing a Twitter space with a bunch of CR people? Yeah, I'm open to it. I am spontaneous is the issue. Like with this now. Okay, I just decided to do this now. I'm increasingly of the opinion, people like David himself, Naval Ravikant, others, that scheduling time is always an issue. I like to work rather spontaneously, and the more people you have, exponentially, the more difficult it is to coordinate things. If someone starts a Twitter space on whatever, and it seems interesting, I'll join in. Elon had one the other day. I was going just at a time which was convenient for me, so I listened in. So I would do the same for any other as well. Yeah. He's also asked, why is having two classes of payers bad? Well, as I said, it's not that for Twitter that having two classes of people, one of whom pays and one of whom doesn't pay is bad. That's fine. I love that model. Have paid subscribers and then the free subscribers. That's fine. The problem is telling everyone. I don't want everyone to know that I'm paying. Why? It's my preference. I don't want everyone. It's exactly like I compared it to, Jesus talked about this. I'm not not a hugely religious person, but this is an old lesson. Jesus chastised the person outside of the temple who was making a big show of, hey, look, everyone, I'm donating to the temple, to the poor people. Look how wonderful I am. Donating lots of money, getting a lot of kudos from the people around him. And then the old lady who had almost nothing to spare quietly going up and putting a little bit of money into the plate, And he said of his followers, who is doing more? Who has given more there? Well, the little old lady who had almost nothing to give but gave what she could, of course, as a proportion, but also because she was modest and humble in doing so. Is there any great virtue in being modest and not being an arrogant? I'm old school and I kind of think, yeah, we know people. Who am I to talk? I'm here on a live stream, but showing off is a thing that is easily spotted out there in the world, easily spotted. And things like that, badges, special hats, stars, whatever. Yeah, I think you should have. If you want to show off, show off. If you want a badge, have a badge. Great, I don't mind. Do whatever you like. I'm just saying, for me, if I'm paying money, shouldn't I be allowed to choose what I spend my money on? Well, unfortunately, I can't right now. I want the additional time for video. I don't want the badge, but there isn't that option. There isn't that option to have the blue tick. Blue tick. I can see a reason for having the blue tick if absolutely every account had a tick of some sort. Absolutely every account had a tick. That would be fine. So then you'd know, okay, yellow tick means bot. Okay, it's a programmed Twitter account that is just automated. There's that one, that Knowledge Theory, that tweets out some of my tweets and David's and Naval's. Great. Put a yellow tick next to that so people know there's no person behind that. I think that's great. And then every actual person gets a blue tick. That's fine. But we don't need one just to say, oh, you paid. Silly. Why should the paying person not have more credibility or power? Well, because it's Morrison. That I think is more obvious. No one has more credibility or power. This is human society. Elon has stated he wants Twitter. He views Twitter as the public square. If it is the public square, everyone's equal. It doesn't matter if you're the king, the chief court justice, the street sweeper, or the scientist. Everyone can talk. Everyone can say, and everyone is a human being, and by that metric, all equal in infinite ignorance. No one has special access to anything, and so thereby that is why no one has more credibility or power. You don't. You simply do not, by virtue of a tick or anything, credential, nothing. Do you have more credibility or power? You can always be wrong. Yeah, you can say you're credentialed. I'm a High Court Justice. I've got a PhD in this. Okay, great. Okay, we would hope that you'd have some knowledge there, but you're no less prone to error. Okay, there's that. Maxine Leroy has asked, are supergiant elliptical galaxies the place where intelligent space-traveling life is most probable? The metallicity of their stars is high, and the formation of ancient which gave more chance for life to appear. Possibly, there is this notion of galactic evolution as well, that spiral galaxies eventually unravel themselves into giant ellipticals. So the giant ellipticals can sometimes have lower metallicity. They generally are huge. Okay, that's why they're called giant ellipticals. You put a giant elliptical next to a your typical spiral galaxy like the Andromeda or the Milky Way, and there is a vast difference in size. These things, there's not many of them that are close by, so it's difficult to see some of these giant ellipticals, which might be in the distant part of the universe, which means you can't tell what's there. We just don't know what planets would be like in other parts of the universe inside other galaxies. We'd expect them, of course, to be the same. It's the cosmological principle. Whatever is true of our region of space, including our galaxies, should be true of distant galaxies as well. Modulo the fact that, the further away you look, the further back in time you look, and the conditions, the actual proportion of things like metals in the distant part of the universe is different as well. So where are the intelligent aliens? Well, you've also got the other problem of, even if the conditions are okay in a very distant region of the universe, favorable for life, you point your telescope and your spectroscope to a galaxy that is 5 billion light years away. Let's call it 10 billion light years away. And you see that it's got all the requisite elements there. Are you going to find intelligent life? Well, the problem then you have is that here on Earth, it took about 5 billion years, 4.5 billion years for intelligent life, human beings, to evolve. Is that approximately how long it takes? So if it's approximately how long it takes, all else being equal, and you find a planet that formed only 3 billion years after the Big Bang, then you might not, okay, because it hasn't had enough time to evolve. Now, we don't know enough about, and we can't constrain these things. If the dinosaurs had not been wiped out by the chance collision with an asteroid, planet Earth, would they still be wandering around? Would they be intelligent? I doubt it. Would people be here? I doubt it, because all the mammals would have been eaten that could have evolved into us by the dinosaurs. So there are just open question after open question after open question. So saying that certain places are more probable than others, I think, is meaningless. We don't have enough data. It's fun to talk about, though, but it's a huge conversation. Okay, so Black Locust has asked, Roger Penrose is brilliant, presumably as familiar with Turing Gödel, computation, etc., as Deutsch. Yet why, contrary to Deutsch, does he say whatever's going in our minds is not a computation? Because he's wrong. Yeah, it's him and Hammerhoff, I think is the fellow's name, that have this theory about the microtubules. And the microtubules are what give us the capacity to have consciousness in our brains, something like that. The consciousness comes down to a quantum phenomena of some kind. I also find this dubious. Penrose, he doesn't endorse the multiverse. He's brilliant, but brilliant people can be wrong. There are many, he doesn't understand computational universality. It's a simple idea, but people can misunderstand simple ideas. Martin Rees precisely has the same perspective, that understanding, he's explicitly said this in one of the debates he had with David Deutsch, that understanding is not a type of computation. But why? Given that what's going on in the brain is a matter of matter doing stuff. The brain is material. It's matter doing things. Whatever matter does is a computation of a kind. It can be simulated by a computer. So therefore, whatever a brain is doing at this level of fidelity, if you wanted to, if in theory in the future you could scan all of a person's brain and the goings on there and simulate that in a silicon computer, in a laptop of the future, then that laptop would be doing the stuff, would be simulating all the goings on in the brain. It would be thinking. It would be doing the stuff that the brain is doing. So the brain is thinking here. It would be thinking there. And if you don't think that, then you're introducing another thing that is outside of the laws of physics. You're just appealing to the supernatural. That's all. Nothing but. So you can say that you're a mathematical physicist and say that you're an astronomer royal and say that you place science on a pedestal. But if you deny that the laws of physics are universal and govern all matter, and that quantum theory governs all matter, that is our best understanding, our best explanation of the world, and that all physically possible processes are computable, and you admit all of that, and then say, but except for the brain and what the brain is doing in thought, you're just supernatural. That's all. People make this mistake. They've always made this mistake. You know, there's always some sacred cow that even the best among us are unwilling to slay, I suppose. And some of us just want to be reason absolutists, for want of another word. Just pursue reason to its absolute extent. Does it mean we could be wrong? No, we're fallibilists as well. It could be the case. It could be the case that this idea that the laws of physics as they're known now are completely off. All right, let's admit that. Tick. Now let's make some progress. Okay, we can't use that. We can't use Penrose's idea or Martin Rees's idea that the laws of physics as they are don't apply to brains, because that doesn't allow us to make progress. What we can do is to start with the best theories we have, pursue them to their uttermost ends, whatever they happen to be, and see what solutions we can find until such time as we encounter a problem. So far, there has been no problem with this. If you want to develop AGI, you better want to have a notion that it's a physical system of a kind. Or it can be instantiated in a physical system, which can replicate what's going on inside of human brains. So, yeah, it's merely when people say, but, and I'm not having a go at you, Black Locust, and you know, but people do bring up Roger Penrose rather often with this, and others. It's an appeal to authority. I mean, you may as well say the local priest thinks the same thing. Okay, what is the underlying explanation they have? They don't have one. We're not saying we can explain precisely how it is that mind and thought and ideas and knowledge arises, explanatory knowledge arises in the mind, on the brain, as a matter of fact, just that it does. And so therefore, this matter, this complex matter we call a brain, can give rise to these things called thoughts and consciousness. So matter can do this stuff. All matter behaves in such a way, interacts in a way that can be captured by a computer, can be stimulated by a computer. So, and if you deny that, you're just denying physics. It's just an appeal to the supernatural, as we say. Maxine says, I think Penrose believes the diagonal argument could not have been found by a finite Turing machine, therefore human. Yes, David Deutsch makes this point as well. Okay, if you write down on a piece of paper your name, and followed by yourself, I wrote down, Brett Hall cannot consistently judge this sentence to be consistent, or cannot consistently judge this sentence to be true, or false, rather. False. Cannot judge this sentence to be false. Then, yeah, it's the liar's paradox. I can't judge that sentence to be false, because if I try to, then it'll be true, and if I deny it, it'll be false. So, yes, you can wrap yourself up in these games of logic, and that's what Penrose does. But anyone else can see that Brett Hall cannot judge this sentence to be false as true. You can see it. I just can't. I can't do it because it refers to me. It's one of these indexical type things, self-referential things. Okay, good. John Ortiz has asked, I'm trying to learn maths and logic. What are some ways of learning this material? Pursue what's fun is all I would say. You know, when I was learning this stuff at university, I just had a natural aversion to certain kinds of stuff. They fed me so much calculus. There was a point at which I remember, calculus is fun, you know, especially when I was trying to teach myself nonlinear differential equations. I was talking about this in a previous talkcast as well, you know, that this was the underlying theory of chaos theory, the mathematics of chaos theory relied upon these non-linear differential equations. So I really wanted to learn about these things and how you could generate fractals. And so I did. And I learned about partial differential equations. So that was all fun. But then the more calculus they kept throwing at me, the more I began to resist it and sort of thought, this is getting boring, geometry I often found boring as well. So you got to find the thing that you find interesting. I always found logic absolutely fascinating. And the reason is because it was like, I knew there was the thing I wanted to understand. I wanted to understand Gödel's incompleteness theorem. And so first I had to understand baby logic and propositional logic, and then the underlying logic of arithmetic, simple arithmetic. And so you had to learn this in order to understand Gödel's incompleteness theorem. And that was fun because I knew I was learning stuff and making progress along the way. So where do you start? Look, for all the terrible stuff I say about high school textbooks, if you don't know anything else, are a great source. I mean, because they've tested themselves against reality. For all that you say that's bad about school and especially mathematics classes, and I would agree, if you want to teach yourself what this thing called calculus is and you have got no other understanding of it, get a high school textbook. Or watch YouTubes and so on and so forth. And the reason I say high school textbooks is because they've had to go through the trials and tribulations of actually working. Teachers, for all their flaws, want a simple to understand textbook that works, that actually teaches kids. There are all sorts of online stuff that you can do as well. In this day and age, online schools and things. YouTube is obviously a great resource, but to practice, you kind of want little maths puzzles to work through. Yeah. So Black Locust has asked, I'm interested in Deutsch's critique of Jared Diamond's materialist theory on the development of the human species. What does David Deutsch think is likelier? Does any historian's work dovetail with Deutsch's? So this is in, I forget which chapter, the chapter on optimism, perhaps. In the beginning of Infinity, he talks about Jared Diamond's account of history, and it's all couched in terms of resources. And, one of the reasons that Western civilization is the way that it is because we were lucky to get to the resources first. It's not concentrating on the ideas. It's not. David focuses on the culture of criticism, uniquely, so far as I can tell. This notion that the Enlightenment can be explained by people rejecting authority and then just coming to have this panopticon vision of criticism applying to everything all the time. And this is the way that improvement happens. And even if you don't consciously know that this is the process, implicitly this is what is happening in society anyway, and you grow up in this culture where it's fine for you to criticize stuff. Okay, there are pockets, where this isn't working as well as it could. Parenting is one. School and education is absolutely another. Okay, children are still not brought up in a culture which is a culture of criticism as well as what the adults are, and everything can be improved. The culture of criticism can always be improved, can always be made better. But this is the thing that distinguishes us and our rapid progress from all those other failed societies. Yes, and so Jared Diamond misses that. Does any historians work? Well, I don't know enough about other historians' work. I know there are some people on Twitter that are very good at this, and they are in history. I can't remember the names right now. You'd need historians that are familiar with philosophy as well to give a better account of societies that have succeeded and the conditions that explain why, and those that have failed. So David Deutsch is providing the philosophical background to why civilization that we occupy has managed to solve the problems at the pace that it has, why it stands apart from everything else. Nothing to do with colonialism and conquest, nothing to do with, let's say, even things like greater wealth. The greater wealth and health and success of the civilization is a symptom of something far deeper, the philosophical underpinnings, the epistemological underpinnings, namely that we have this relationship to knowledge. We have that relationship to knowledge because of our relationship to physics. The relationship to knowledge in particular is everyone can have it. everyone can have knowledge. It's not just the domain of the king and the priest and the holy book. Everyone can come to understand the world. And in fact, that's necessary. We now understand that, this is important that everyone learns to read and write and come to an understanding. We celebrate, the children becoming better. Unfortunately, we don't do a very good job. They learn in spite of our terrible tradition of learning, but at least we recognize that it's wonderful that people learn and create and so on and so forth. And the central part of that is to criticize, to not have great deference to the leaders and the experts and the priests. Not to say don't have respect and don't understand that some people know more than you and all that sort of stuff. All that's fine. But even if the person does know more than you, that is not an argument for them being able to compel you to do what to do. You could always, the person that knows the most can always be in error. And the person that knows less should always be able to make the mistake to some extent. You don't want them to lose their life, but you want them to also learn by their own lights, okay, rather than just being told or compelled and so on. Apologies. Thank you, Levi. Levi said good work on the recent video on climate. Next question. What can governments or an organization do to accelerate the growth of knowledge? All the things that I said in that exact video about degrowth. The growth of knowledge is intimately tied to the growth of wealth. The growth of wealth is intimately tied to growth broadly in things like population, energy production, technology, all those other things, agriculture, etc., etc., etc. The growth and flourishing of the human species is intimately tied to knowledge creation. Change any one of those and you will reduce the others. They are necessarily dependent upon one another. Reduce the amount of wealth, you will slow down the growth of knowledge. Reduce the population and you will reduce the growth of knowledge. More people means more ideas. Restrict the amount of energy so that things become more expensive, reduce the amount of wealth, reduce the amount of the rate at which knowledge is produced. Things get better. And look, being an optimist, I accept the fact that things get better all the time. There are moods in which I can be a pessimistic type of optimist in the mold of David Deutsch by saying things like, it's always possible to have the progress even faster than what it is. And that it upsets me when there are obvious things going on, seemingly obvious, that are slowing down the rate of progress, not progress altogether. It's not like we're going backwards. I'm not with the people who say certain things are causing regression. I don't think that's true. That's overhyping things. That's hyperbolic. But any simple change like reduce the income tax rate, which causes people to want to go out and earn more money, it gives them motivation to do more stuff. That's a simple change that could increase the rate of knowledge creation. So what can governments do? Governments can just, it's the standard take that people on that side of politics have. Reduce taxes and reduce regulation. That's it. There's really nothing magical about that, because taxation is nothing but taking from people who produce to give to people who don't, namely, or to put in the hands of people who don't, namely politicians. So politicians then decide what's going to happen with that money rather than the business owner who was using the money to make more money. You have to create wealth. Wealth is not a fixed pie. There's not a fixed amount of resources and a fixed amount of money. No, you create it. When you take those resources out of the ground, you rearrange them in different ways to make widgets and things, which make everyone wealthier. The cost of the material, I'm speaking to people right now on a MacBook. And the MacBook has rare earth metals and it's made of aluminium and plastic and stuff. Those materials on their own, taken out of the ground, what? I don't know. Maybe there's a tiny little bit of gold in there and palladium and tantalum and rare earth metals and so on. You add it all up, I don't know, maybe it comes to $50 American. Okay, that's like the lithium in the battery. Maybe that comes to 100. it certainly doesn't come to the some thousands that the computer is worth, right? So why? How has it gone from this raw materials that were worth some hundreds of dollars, when rearranged, become a device worth thousands? The wealth has been created. That additional cost has been created. Where? By people's knowledge, by the inventor and the creator's knowledge and the work of people, not merely putting the thing together, but primarily having the idea in the first place. The descendants of the Steve Jobs of the world, who came up with the first Apple computers, are the ones who've created that knowledge and continue to create that knowledge, which is creating the wealth once it is put into the resources to create that thing we call a piece of technology or a laptop computer. So, yes, so how can governments create more wealth? Reduce the regulations on companies that are actually doing precisely that sort of thing, that are using resources and transforming them into technology. Because the wealth is held within, it's almost like it's held within the bonds that hold together that bit of technology. The truth is, it's held within the abstract relationships between the atoms and molecules of the resources that now come to make up the computer or the smartphone or the car or the aeroplane or whatever it happens to be, whatever the bit of technology is. It's the plan written down on a piece of paper or stored in memory somewhere that is really worth something. Where did that worth come from? From people's heads. But they can't do that. They can't do that as well if they don't have enough money to do the research and have time to do the thinking and all that sort of stuff, which only comes with increased wealth. So governments have to figure out ways to increase wealth, and the way to not increase wealth is to tax people. The way to not increase wealth is to have regulations on what kind of products can be produced or under what conditions they can be produced and that kind of thing. As Yaron Brook points out, companies of the world do not want to kill their customers. You don't need to have government regulations on things like elevators. And I know some people balk at this idea, but it's not a good plan for elevator manufacturers to kill their customers. As soon as you get known as being the person who makes the elevator that falls 15 floors, okay, you're not going to be contracted to work in the next high rise. No, we want and in fact, of course, we know now that the overwhelming majority of companies, whatever industry they're engaged in, regulate themselves far more than what the government regulates. But the government likes to regulate, which means they have to employ regulators. They have to write laws about all this stuff. That all costs money. And so, yeah, the government should be there to protect rights. And to the extent that it's not there merely to protect the rights of consumers and traders and citizens, and it's getting into other areas, is slowing growth, knowledge growth in the energy area, growth everywhere. If you want an existential threat, I'd say that's one for you, because we're not often making progress fast enough. Adil Zishan, could you explain what scientism is and why it is wrong? Yeah, scientism is the application of science to things that are not scientific. So if I want to know, once I finish this live stream, it's coming up to Christmas. I have to buy Christmas gifts for people. I have a few people in mind that I've got to get Christmas gifts for. If I was to say, well, I've got to do a scientific study to figure out what is the best Christmas gift to get my, nieces and nephews. That's what I need. I need to run a scientific study of some sort. Get an average of people that age, something like that. Do an experiment. This is scientism. This is the wrong question. What I should do in the future is a matter of preferences for a particular individual, preferences for me. This is the domain of morality, not science. Science is about what is the case. And if you're very lucky with certain physical systems, you can make a prediction about what will be the case under certain conditions, but it can never tell you what should be the case. And yes, of course, you have people who say, well, if you can measure the well-being of people, then you can maximize well-being in the future. The problem here is, what counts as being good for well-being right now? How do I know that getting a Mac rather than a PC produces more well-being? And if I scan the brains of people who already have PCs and Macs, does that tell you what I should get What is the more moral purchase to make? Morality is about the domain of shoulds. Science is about the domain of ises. Scientism is attempting to bridge the gap, often for authoritarian reasons. When I say that, I mean it's the expert scientists trying to do something other than science, trying to say, hey, I'm an expert scientist. I have a PhD in science. And so therefore, politician, you need to listen to me. Do you want to refuse to listen to expert opinion? Of course they don't. This is science. This is the problem with scientism. It's a form of authoritarianism, often masquerading as scientific rationality. It is quite possible that certain scientists have, what do you call it, small man syndrome. It's like I'm not being listened to enough. I've told you, damn it, climate change is coming and it's going to kill us all. So they start writing articles and saying what should be done. It is more than reasonable and valid for climate change scientists to tell us what the state of the climate is, to tell us what their models are, and to tell us what their models are going to predict. They can suggest what the solution should be as well. And it's incumbent upon the rest of us to say, well, models always have elasticity. Models are only as good as the laws that you're using to govern the system, the laws you think exist that govern your system, the conditions you think you've been able to measure to produce the prediction, always exceedingly difficult, and for reasons that we won't go into right now, perhaps impossible. So it's incumbent upon the rest of us to say, yeah, look, we respect what you're saying as an expert, as a scientist. We respect the idea that you've got this scientific model, but we also know that models are very much open to error. And you only need to have small errors. Some of these things are very susceptible to small changes for the prediction to be way off. That's one thing. And the other thing is, your job is to tell us what is the case and to tell us what you predict is going to be the case. It shouldn't be also to command us about what we should do, especially when it comes to economic policy and energy policy and any other kind of policy. That's the job of the politician. Politicians are very weak at the moment, quite around the world. And by weak, I mean because they defer, they outsource their decision-making to the expert. This has happened especially during COVID, but everywhere else. And they shouldn't. They shouldn't, because one consideration is science, one consideration. Another is the economics. Another, for want of another word, is the well-being of people, cohesion of society. Any number of other factors that are absolutely as important as what the science says. And by the way, problems are soluble and optimism is a thing. And politicians are singularly unaware of this philosophy of optimism and how problems are soluble and we do not need to try and prevent problems. But all of them are animated right now, especially when it comes to, all of them are participating in a scientism experiment right now with respect to climate change. Because the climate change scientists and others in the intellectual community who are typically scientists as well or have some scientific understanding are precisely the ones prescribing certain economic theories, because the culture in amongst those intellectual communities of scientists is a socialist leaning. It's a leaning towards more government, more taxation. And why? Because often they're engaged in universities and other sectors where they earn their money from taxation, from government. They're employed by the government. So of course they're going to support government action and support big businesses paying more taxes because it's good for them. That's where they get their funding from. Of course, all of the climate scientists at Cambridge University are going to be unified on the notion that we need more government taxation of high polluters and regulations. Why? Because they will be the beneficiaries. More money for the universities. More money for me as a lecturer of climate science. Yeah, so we have to be, I am very skeptical about certain areas like that, unfortunately. But to some extent, I say they've done it to themselves. They've done it to themselves by over-egging it year after year after year after year. And it becomes tiresome. And it also becomes tiresome as just a regular layperson citizen, as I am, listening to Politicians talking about the one problem, the one issue, fixated on them because it's also frightening. Not frightening for what climate change might do or anything like that. Frightening because they're not looking at other stuff. They're not paying attention to other things. There's social cohesion, nuclear weapons, terrorism, just funding fundamental science might be a start as well. Yeah. Okay. What can you do? So that's scientism. Abraham has asked, can you explain the Kuhn versus Popper argument? Probably not in the time I'm going to allow myself left, which is, let's say, another 15 minutes. The Fabric of Reality, the final chapter of the Fabric of Reality, has a wonderful explanation of Kuhn. Thomas Kuhn, look, Thomas Kuhn, to some extent, he was a realist, but it's what his movement led to that is really the problem. He thought that scientists were of one of two sorts. Either you're a scientist who was the old fogey, who would refuse to move on their most cherished theory that they discovered decades ago, or you were the young upstart who had a new idea, who couldn't get their ideas published in the mainstream, journals and so on and so forth, because the old fogies were in charge, and you had to wait for the old fogies to die off before the young upstarts were able to get a foothold. This was Kuhn's idea, roughly speaking. You had the old paradigm and the new paradigm. And if you were in one paradigm, you didn't understand the other paradigm. But it's all wrong. It's all wrong. Scientists do, in fact, change their mind. Okay. People can be persuaded. There is a lot of mixing between the different paradigms. Einstein was trained in classical physics, but he invented or helped invent quantum theory and general relativity. General relativity on his own, quantum theory with a bunch of other people. All the original quantum theorists, all of quantum theory was invented by people who were trained in classical physics and who understood classical physics. Newton was building upon, who'd gone before, who would have disagreed with him. So there's that. So Kuhn had this idea, tried to paint a picture of the project of science as being similar to the way in which fashion works. That, you like this particular theory, you like wearing this style of clothes, and the younger people like something different, a new idea, different fashion. And so it wasn't like you're objectively turning over, getting closer to an explanation of reality, a better explanation over time. You were just moving from one theory to another, from one paradigm to another. And Popper said, no, this is not what's going on. You're actually making objective progress. You're actually improving and finding something out about the objective real world. It's not merely fashion. Popper can accept that there are sociological forces at play. Absolutely. No one denies that. No one denies that scientists don't live in a community. I was just talking about that. And that people can become wedded to their theories and identify themselves with their theories and so on and become defensive and all that sort of stuff. But the thing is, this does not explain science. Science is explained by Popper. The fact that we do make progress, the fact that these changes over time, incremental and large, really do point in the direction of progress with, backward steps now and again. What happens in science is not accounted for by Kuhn. It's a minor side issue. The fact that sometimes the old fogies stand in the way of the young upstarts. Sometimes that happens, but that is not an explanation of what's really going on or why it is. Quantum theory takes a while to be understood. Quantum theory comes to be understood pretty rapidly, actually. It's taken decades, okay? Newton's theory was around for centuries. So, yeah, I would say worth understanding Kuhn simply because his ideas lead to a decades-long tradition, and basically that's the most cited work in the humanities remains Kuhn's The Structure of Scientific Revolution. He led to a whole bunch of movements which became increasingly relativist, increasingly of the idea that it's all merely a matter of opinion. There is no objective knowledge being created here. It's just your preference. You want to be a classical physicist and endorse the idea that things can be divided up continuously. Oh, that's your opinion, a matter of taste. Okay? Or you can think that things are discrete, and that's quantum theory. There's no objective truth in the matter. that's where it ends up. It ends up in places like that, and places like, well, the entire project of science is corrupted by the white male patriarchy, and we need to do away with the whole thing because it's inherently racist and colonial. That's where you ultimately get. You can draw a straight line from that to Kuhn. Now, Kuhn is not responsible. Poor Kuhn, Thomas Kuhn, for all of his flaws, he didn't mean for that to happen. He couldn't have predicted it. But that's the seeds of relativism are there, unfortunately, for Kuhn. So that's that. Okay. Zombie and James has said, if someone has a different ethical system than us, how can we argue that one is better than any other? That's a good question. We begin with principles that we know, best explanations. For example, coercion is an evil. We should try and remove coercion everywhere that we can. Why? Well, it comes back to knowledge. Knowledge is created in a free, creative environment. And as soon as you're being coerced people, you impact upon their reason. You prevent them from being able to think in certain ways and do certain things to create knowledge to solve problems. We want to solve problems. Okay, this is an objective good about the world. And if you want to deny that solving problems is an objective good about the world, you're now a relativist. Okay, and so I will take you at your word. You're a relativist. Then you can't be persuaded. And so, well, there's no point us talking. But if you're not willing to go that way, if you're willing to say, yeah, there are objective facts about reality, namely that there are scientific truths, there are ways in which we can improve science, okay, we can actually come to a better understanding of the world, we can generate better explanations, then certain shoulds follow. Then we should be open to evidence. We should be willing to allow people to have an exchange of ideas. We should be logical and reasonable and etc. So in this case, there must be objective differences between ethical systems. Anyone who says, oh no, we should not allow any girls to go to school ever, they should be coerced and kept at home. Well, okay, for many reasons, but if you want an epistemological reason, this is a evil thing to do for them, for individuals, but also for civilization, because now you're cutting off progress and creativity. We want those girls to be able to think of solutions to problems for them and everyone else. And they can only do that if they're free and not coerced. So there is a black and white difference between different ethical systems. Some are objectively better than others. Some allow for progress. Some allow for human flourishing. Some reduce coercion, and some seem to try to maximize it. And that's how we can judge. It's one nice heuristic. David Deutsch's fundamental heuristic is do not destroy the means of error correction. This is the thing that allows for progress in all areas. If you shut off a means of error correction, then you're doing the wrong thing, because error correction is the very thing that allows you to make progress and improve things to solve problems. A means of error correction is a person is a means of error correction. That's what we are doing. And so if you coerce, force, let alone kill a person, this is wrong, because destroying the means of error correction is wrong. And there's a lot of ways to destroy the means of error correction. Killing a person is one, but just simply coercing them and forcing them to do what you want is wrong, morally reprehensible, because it's epistemologically reprehensible. Okay, so hopefully that, yeah. Adil Zehan said, Hume said, reason is and ought only to be the slave of the passions and can never pretend to any other office than to serve and obey them. Does a Popperian agree? Well, I don't know. The question is, does a Popperian agree, disagree? Why? I don't know. Who's this generic Popperian? But I would say that it depends upon how you interpret Hume. There was I think in the Knowledge and Ignorance series that I'm in the midst of, or at least 3/4 of the way through, we talk about Hume and these ideas. And I don't think there's a sharp distinction here to be made between reason and the passions. There's this whole idea of reason versus emotion. And I don't see that we need to make this sharp distinction between these two things. Your passion can be quite reasonable. Any emotion you have, it can be reasonable to be fearful of the bear with claws in front of you. Fear is a reasonable emotion in that situation. Anger can be a reasonable emotion. Happiness can be a reasonable emotion. Okay, so Reason only the slave of the passions? I don't know about that. Why? There are situations where you might be fearful irrationally, in which case your reason should not be the slave of the passions. If you've got a phobia of an irrational phobia of certain things, okay. I happen to be on the 8th floor right now. If I look out, it's quite a distance down to the road below me. If you have an irrational fear of heights, then I don't think that your reason should be a slave to that. To that extent, it should be. You should, of course, not want to jump over. Okay, but in general, phobias in general, you should not want them to be. You should not want them to be. Okay, you should want to use your reason to master your passions. In that case, so it would be the other way around. So I don't think the reason always has to be a slave of the passion. Sometimes you might want to use your reason to overcome the passion, to overcome the emotion. I think this is, but it depends upon the way in which you interpret Hume and what he was talking about. What is the significance, Patrick? What is the significance of the fact that certain infinities are larger than other ones? I would say to Patrick, go to the beginning of infinity, a window on infinity, chapter I can't remember, and I've made a couple of videos about this. The significance is that some are countable and some are uncountable. There are certain physical things, we talked multiverse earlier, where you can meaningfully count stuff, and then in other senses you can't meaningfully count stuff. My rough and ready way of explaining the difference between these two things is to say that the integers are countable, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You just keep on counting them. Obviously, they're infinite. But the decimals are not. Okay, if I start at 0 and I try and get to 1 by counting the decimals, I can't even start. It's not countable. So I could say, well, what about if I go 0.2, 0.1, 0.2, 0.3? Well, yeah, but there's a decimal smaller than 0.1, 0.01. There's a decimal smaller than that, 0.0001. So there's nowhere to start. If I want to start counting all the decimals between 0 and 1, I won't get there. So this is a larger infinity, the uncountable infinity. What's the significance? Well, isn't that significant? Some infinities are bigger than others. Naively, infinity is just infinity. They're all equally infinite, but they're not. Some you can't put in one-to-one correspondence with the others. Okay, so the even numbers, 2, 4, 6, 8, 9, 10, are in one-to-one correspondence with the integers, 1, 2, 3, 4, 5, 6, 7, 9, 10. You might think, okay, don't the integers, 1, 2, 3, 4, 5, 6, 7, 9, 10, have more numbers than the even numbers, 2, 4, 6, 8? Because after all, you've taken away the odd numbers. The even numbers, there's less of them, right? No, because for any even number, you can assign it an integer. Okay, 1 to 2, 2 to 4, and so on. Okay, so you're not going to run out of integers or even numbers in that way. So it's one-to-one correspondence, countable infinities versus uncountable infinities. I don't know if that's significant. Merry Christmas, Richard Martin. Yep. And lastly, Patrick, could you explain the diagonal argument made by Deutsch in chapter 15, the beginning of infinity? Why is the hotel never full? I won't now. I do go through precisely that argument in my video on a window into infinity. So I'll just refer you to that for now. But we've gone to the 2-hour, 20-minute mark. And people have also asked about theories of consciousness. Well, we could go into that. And Adil, when David describes fun as explicit, inexplicit, and unconscious ideas taking account of each other, does he mean the removal of any barriers that stop each of them correcting errors in the others? I suppose so, yes. When you're having fun, it's not like you can put into words exactly why things are fun. After all, fun is this sensation that you also have that accompanies engaging in certain activities. So there's this inexplicit stuff. Unconscious also, because what you're doing often is not something you have to think carefully about. You're just in a flow state. But of course, there will be the explicit stuff that you're actually doing as well. So for example, this that I've done now has been fun. And I can say it because that's all my explicit words. It seems to have all been explicit. But of course, I've had the inexplicit fun, which I can't quite put into words about that. And me talking, it's been largely unconscious. It's not like I have to think about what words coming out of my mouth next. So yeah, we're correcting errors in all of those. So I agree with that concept of the fun criterion. Until next time, yes, have a Merry Christmas. This was a lot of fun, but I'll probably have another podcast out soon. Until then, bye.